Hello students, in this video I will discuss with you defects in solids. Let us understand what we mean by defect. In a crystalline solid, particles occupy some positions in a regular arrangement, and any deviation from this regular arrangement is called as defect in solid. These defects generally appears at higher temperature because at lower temperature atoms or ions in the compound occupy at occupy their ideal positions. These defects mainly are of two types: electronic imperfections and atomic imperfections or point defects. Electronic imperfections arises due to presence of electrons. At higher temperature, in any covalent compounds, some of the covalent compounds starts to break down, and due to breaking of these bonds, some electrons get free, and at the place of that covalent bond, hole is created. So this is the defect in the compound, and due to the presence of these holes and extra electrons, covalent compounds show electrical conductivity. Second type of defect is atomic defect or point defect, and these defects arises due to deviation in the arrangement of atoms or ions in the solid. This may be again of two types: vacancy defect and interstitial defect. Vacancy defect arises due to vacancies inside the crystal lattice at the places of ions, and interstitial defect arises due to occupancy of interstitial site by extra atoms or ions. Due to vacancy defect, density of the crystalline solid becomes less, and due to interstitial defect, its density becomes more. Next, we'll discuss defects in ionic crystals. Defects in ionic crystals may be of three types: stoichiometric crystal defect, non-stoichiometric crystal defect, and impurity defects. First, we will discuss stoichiometric crystal defects. Stoichiometric crystal defects are found in stoichiometric compounds. These compounds, in which the number of positive and negative ions always remain same, are called as stoichiometric compounds. तो इस तरह के कंपाउंड्स में डिफेक्ट अराइज होगा, तो डिफेक्ट के बाद भी कैटायन और एनायन का जो रेशियो है वो एक जैसा ही रहेगा. अगेन stoichiometric crystal defects are of two types: Schottky defect and Frankel defect. First, we will discuss Schottky defect. Schottky defect is that defect in which some of the anions or cations are missing from their position. If anion is missing from its position, then cation is also missing from its position, and in this way compound remains electrically neutral, and ratio between cation and anion also remains same. Because of this Schottky defect, density of solid becomes less. This type of defect is shown by those ionic compounds which have high coordination number, and of course the size of both ions when similar, then this type of defect is seen. Frankel defect is that defect in which any ion is missing from its original site, original position, but it is present in the interstitial site of this crystal. यानी अपनी जगह पर तो नहीं है, यहाँ पर आयन होना चाहिए था, बट यहाँ पर ना होकर के ये इंटरस्टिशियल साइट को ऑक्यूपाई कर लेता है. सो दिस टाइप ऑफ डिफेक्ट इज कॉल्ड एज फ्रैंकल डिफेक्ट. This defect is shown by those compounds which have low coordination number, size of anion is more than size of cation. क्योंकि यहाँ पर वैकेंसी डिफेक्ट भी है, इंटरस्टिशियल डिफेक्ट भी है, तो यहाँ पर डेंसिटी पर कोई ज़्यादा इफेक्ट नहीं पड़ेगा. Examples are silver chloride, silver bromide and zinc sulfide. Next type of defect is non-stoichiometric crystal defect. This defect is found in non-stoichiometric compounds. Non-stoichiometric compounds are those compounds in which the ratio of positive and negative ions present in the compound differs from that are required by ideal chemical formula of the compound. For example, vanadium oxide. This compound has formula VOX where X lies between 0.6 and 1.3. Now these defects are of two types: metal excess defect and metal deficiency defect. Metal deficiency defect arises due to extra positive ions in the crystal, and metal deficiency defect arises due to extra anions in the crystal. Metal excess defect may arise either by anionic vacancies or by presence of extra cations in the crystal. Let us discuss anionic vacancies. In the case of anionic vacancies, negative ions may be missing from their lattice site, leaving holes behind in which the electrons remain to maintain the electrical neutrality. For example, when crystal of sodium chloride is heated in the vapor of sodium, then some of the chloride ions from the bulk phase go and diffuse at the surface and combine with some of the sodium atoms to form sodium chloride. For this combination, sodium atoms which are present in vapor, they loses some of their electrons, and these electrons come and trap in the anionic vacancies. So in this way, electrical neutrality of the crystal remains same, but since electrons are trapped in the crystal, so crystal becomes colored. These centers where electrons are trapped are called as F centers, and these F centers are responsible for the color of the crystal. Next we will discuss metal excess defect due to presence of extra cation in interstitial positions. In this type of defect, generally non-metal, which is anion, leaves its place, leaving behind electrons at its place. For example, when zinc oxide is heated, some of the oxide ions get removed from the crystal and extra zinc ions occupy interstitial positions, and in the nearby places electrons also occupy position to maintain the electrical neutrality of the crystal. Due to presence of electrons at the interstitial positions, zinc oxide turns yellow at high temperature. So in this way, metal excess defect can arise. Now next type of non-stoichiometric defect is metal deficiency defect. This defect may again arise by two ways, either by cation vacancy or by the presence of extra anions at the interstitial site. मेटल एक्सिस कैसे होगा? एनायन मिस हो जाएगा, तो यहाँ पर मेटल डेफिशिएंसी कैसे होगा कि मेटल आयन मिस हो जाएगा, कैटायन मिस हो जाएगा अपनी पोजीशन से. So first is cation vacancy. In a crystal of such type of compounds, some of the cations, if missing from their position as shown in the diagram, it is the crystal of iron sulfide in which Fe+2 and S-2 ions are placed side by side. If in this crystal some of the Fe+2 ions, for example 3, 1, 2 and 3 are missing from their position, then +6 charge is less as compared to minus charge. To maintain the electrical neutrality, two vacant positions are occupied by Fe+3 ions. आयरन अपने हायर ऑक्सीडेशन स्टेट में आ जाएगा और एक पोजीशन वेकेंट रहेगी. तो कैटायन यहाँ से मिस हो गया. सो दिस इज द केस ऑफ मेटल डेफिशिएंसी डिफेक्ट. ओके. Second type of defect is, as I told you, extra anion if occupy interstitial position. Any anion Suppose this one occupy interstitial position. So to maintain electrical neutrality of this crystalline solid, cation position, one of the cation position occupied by cation of higher oxidation state. यहाँ -1 एक्स्ट्रा आया तो ये +2 आ गया. So in this way crystal becomes electrically neutral. But this type of defect is very rare. Why it is rare? Because anions are larger in size. So larger size anion not easily get fit in interstitial positions. Yes, one more thing. मेटल एफिशिएंसी डिफेक्ट जहाँ से हो रहा है तो उसके कारण जो कंपाउंड है, क्रिस्टल है, वो इलेक्ट्रिकल कंडक्टिविटी तो शो करेगा ही, बट ड्यू टू प्रेजेंस ऑफ वैकेंसी एंड ड्यू टू प्रेजेंस ऑफ सम ऑफ द हायर ऑक्सीडेशन स्टेट आयंस, इलेक्ट्रॉन ट्रांजिशन starts, and hence these type of crystals which has metal deficiency defect, they shines like metal, means they have metallic luster. Example is iron sulfide. It shines like gold and hence it is called as fool's gold. Now next defect is impurity defect. This defect arises due to presence of impurity either at lattice points or at interstitial sites. So if impurity present at lattice points, the position of ions are called as lattice points. So if any foreign ion will occupy these lattice points or it will occupy interstitial site, then impurity defect in crystal arises. Example is given here. It is the crystal of sodium chloride shown here. This position should be occupied by sodium ion. Okay, but here we are able to see strontium ion. सोडियम आयन अपनी ओरिजिनल साइट से मिस हो गया. इलेक्ट्रिकल न्यूट्रलिटी मेंटेन करने के लिए फॉरेन आयन स्ट्रोंशियम आयन with higher oxidation states comes and occupies the space. So electrical neutrality remains same, but due to presence of foreign ion, it is a kind of impurity defect, and of course it is a type of vacancy defect also, क्योंकि यहाँ पर vacancy create हुई है. Okay, so this is all about defects in crystals and defects in ionic compounds. In my next video, I will discuss with you electrical conductivity and magnetic properties of compounds. Thank you.